Good afternoon, ladies and gentlemen. My name is Aryan. I'm from PI Institute, and
Yeah.
I will be the next moderator of this session. Without further ado, we will move forward to the next presentation entitled Hosting Capacity Analysis for PV Rooftop in Indonesia, study case in Gayo Lues District Aceh, which will be presented by Mr. Fajar Triwardana. Mr. Fajar, are you
Yes, Mr. Aryan.
okay? Get ready to answer the question. Mr. Host, would you mind please play the video for Mr. Fajar?
Hello, good night. My name is Fajar Triwardana. I am here to present my paper entitled Hosting Capacity Analysis for PV Rooftop in Indonesia, study case in Gayo Lues District, Aceh. This paper submitted in ICT-PEP 2020 conference. So the authors of this paper is me myself. My name is Fadit Wardana. Um, I currently work in PTPN Persero. I was graduate from Electrical Engineering Universitas Indonesia, and my partner joined in this paper. His name is Tubagus Riady. He also works in PTPN Persero and in the same branch office with me in Aceh, and he was graduate from Industrial Engineering Universitas Gadjah Mada. I will start from the introduction. So this paper takes topic about new and renewable energy in Indonesia. The percentage of new and renewable energy on the fuel mix of electrical power plant is about 15% in 2018 and expected will increase into 23 in 2025 based on the National Energy General Plan. And as written in National Energy General Plan, the new and renewable energy in Indonesia is classified uh, to hydroelectric power plants, solar power plants, wind power plants, biomass power plants, and geothermal power plants. So we will focus on solar power plants. The potential for solar electric is energy at 4.5 kilowatt hour per meter square per day in Indonesia, and particularly 5.1 kilowatt hour per meter per day in Aceh province. Distributed generation can define as electricity source that is connected directly to the distribution network to supply a local consumers and support the distribution network. These definitions from the International Energy Agency. So the distributed generation is usually as the small scale power plant. Distributed generation can come from renewable energy source such as wind turbines, photovoltaic, micro hydro generators, and biomass. And also can come from fossil fuel energy source such as small gas turbine, internal combustion engine, and micro turbine. The service scheme of PV rooftop shown in this picture start from the solar energy that convert into the electric DC power and will go to the DC breaker for the protection, and the next step it will convert into AC power through the inverter. After that it will go to the power control center or PCC panel. The power from PV rooftop can be used by customer itself or it can be exported into the PLN grid through the export-import calorimeter. In case there is no power supplied by PV rooftop, PLN grid can supply the consumers through the export-import calorimeter as usual. So this picture in left shown the service scheme of PV Rooftop, and the picture in right is shown the PV Rooftop registration process in Indonesia. There are two types of the PLN consumers, the prepaid and the postpaid. The postpaid consumers will be able to transfer the power into PLN from his PV rooftop installation. The procedure of the registration is start from the consumer's request. Customer should make a request to the PLN, and PLN will verify the request, evaluate it and verification, and if approved, the next step is third party will make the PV installation, and the authorized institution will publish the certificate for operation or SLO. And the last step is PLN will install the export-import calorimeter. The amount of the export from the consumers will compensate in the monthly electricity bill. So I will go on into the theory review. As known before, the PV rooftop of the distributed generation, PV rooftop is one of the distributed generation. If many distributed generation supplied into the power system, it will affect the performance of the power system. It can be better or worse, and it can be observed by a few performance index such as overload, overvoltage, from the losses aspect, frequency, and the harmonic in this system, and reliability and the economic aspect. All of these aspects can help us to determine the limit how much the distributed generation can supply into power system. Next, I will describe about hosting capacity approach. Hosting capacity can be approached by observe the performance index of the power system. There are three states of performance index. So by adding or decrease the generation, the performance index will going to improvement state, or the deterioration state, or the acceptable deterioration state. To know how much the generation can be connected, it's important to define appropriate performance indicator. The hosting capacity is based on this. In this paper, active power is selected as the performance index. From the limitation, there's a limitation amount installed installed distribution generation. It's now the hosting capacity. So the performance index and limit. The total downstream active power consumption is equal to P cons T, and the total downstream generation is equal to P gen T. The reactive power is neglected, so the total power flow is P equal to P cons minus P generation. Before PV rooftop installment, there is no overload occur in the feeder. The condition will be P max is less than P consumption max. With the large amount of installed PV rooftop connected to the grid, The maximum power flow occurs for the maximum generation and minimum consumption. P max equal to P generation maximum minus P consumption minimum. In order to guarantee the system is not overloaded, the following terms should be followed. P generation maximum minus P consumption minimum is less than P maximum limit. And then P generation maximum is less than P max limit plus P consumption limit. From the equation 5, we can be seen that the maximum allowed amount of generation is depend on customer consumption. So for the study case, we observe the Putri Betung feeder that is located in Gayo Lues, Aceh. This feeder operated radially and using 3 phase overhead lines in 20 kilovolt voltage, and it also using conductor all aluminum alloy conductor and using the size of 70 millimeter square. The feeder is 51.58 kilometer circuit length. Approximate the last 5 transform of Putri Betung feeder is installed the PV rooftop as the distributed generation. The last 5 transform have the same capacity, which is 50 kilovolt ampere. We can see in the table the ampacity of the conductor is about 255 ampere, and also the max permissible power in MV megavolt ampere is about 8.82. For the hosting capacity calculation, we observe the load from all of these transformers that can be shown in the table, both of reactive and active power, and also both of the max and minimum power. Section A and E have the greatest value from the section. The left table is the consumption data for each section of the feeder, both of the maximum and minimum consumption. And then from the equation 4 and 5, we can elaborate the hosting capacity and we can determine it into all of these value in the right table. So for the conclusion, I can describe that this paper explains a general overview of PV rooftop regulation in Indonesia. And the study case taken from Gayo Lues district, particularly in Putri Betung feeder. From the hosting capacity obtained, the amount of PV rooftop can be connected to the grid is about 50% of installed capacity. The 50% value states by considering the load type of this feeder is dominated by household in rural area. And install the PV rooftop is important to be implemented to support the power system in this area. For your information, the Putri Betung Gayo Lues have the tough circumstances. It has a isolated isolated power system. It's in there that it's not connected into the big grid like 145 kilovolt grid. So it also isolated in 20 kilovolt grid. And then thank you so much for watching this video and good night.
Okay, thank you very much, Mr. Host. Uh, a good presentation from Mr. Fajar. Mr. Fajar, do you have anything to add for your presentation?
I think I have to say in this paper only takes study case in Gayo Lues that the region of this power system is isolated and didn't didn't connect into 140 kilovolt grid.
Okay, so
That's all.
isolated. Okay, thank you. We move forward for the question and answer session. Is there any question for Mr. Fajar and Christine regarding his presentation? You may raise your hand or... Okay, Mr. Muhammad Ikromi, please turn on your mic.
Alright, thank you. Well, this is a very interesting topic, but my question is a little bit simple. Have you ever calculated or evaluated the solar energy potential in the study case of uh, your study? What's the potential? Is it potential enough or not? Is it sufficient or not? Thank you.
Okay, thank you, Mr. Ikromi. Please, Mr. Fajar.
All right, thank you, Mr. Ikromi, for the question. I will try to answer this question. In this paper, during this paper, I and my partner, Mr. Tubagus, only elaborate the hosting capacity. So, because of this Putri Betung region in tough situation and tough condition because of the geographical in dominates with valley and mountain. So we think there are a solution about the PV rooftop, and we didn't study about this potential solar in this area. We only got the data from the NASA data, and I think for this study we need further study on further research. Thank you, Mr. Ikromi.
Okay, thank you, Mr. Fajar. Another question is from Mr. Tri Hadimasya from PLN. You mentioned in your presentation that in determining the hosting capacity, we need to consider the parameters of the feeder or equipment. So the question is, in your paper, what are the parameters of Putri Betung feeders that are you considered in determining the hosting capacity?
All right, thank you, Mr. Tri Hardimansyah from PLN Pusditbang. The parameter of Putri Betung feeder, because of this Putri Betung operates radially. In the about 50 kilometers, the feeder only operates single circuit and radially through the mountain and valley. And the Putri Betung feeder is have the load diversity, the load, the trafo from this Putri Betung from one and other trafo is in far distance. So the parameters make me and my partner to decide this feeder to observe in this paper. Thank you.
Okay, is that answer your question, Mr. Tri?
Okay, thank you very much for the explanations. I think it's enough. Thank you, Mr. Aryan.
Okay, thank you, Mr. Fajar, for the answer. We have another one question. We have only 1 minute left. Maybe we can answer from Mr. Ricky Adrian. I believe the maximum capacity PV rooftop depends or limited by the capacity of MCB in-house capacity ratio. and also capacity ratio of 20 kV conductor. 70 millimeter conductor is about 3 megawatt. How can you calculate it's only 50%?
All right. Thank you, Mr. Ricky Andrian. And this hosting capacity theory, as shown in my slides before, hosting capacity analysis, there is some method for the determine the hosting capacity. One of the method is from the overload method, and from the literature that I studied, the hosting capacity analysis depends on the active power overload, lead us to determine the hosting capacity is about 50%. This value is considered to about the because of the transformers in these 5 transformers that we research. It's only 50 kilovolt ampere capacity. So from the calculation that I shown in this slide, I decide to the 50% only the distributed generation can install in this feeder. Thank you.
Okay, thank you, Mr. Fajar. Hope it will answer your question, Mr. Ricky. What a great presentation from Mr. Fajar. We give a round of applause for Mr. Fajar in this